Hi, so today I'm going to do a couple more problems from chapter 6 on frames and machines to give you a few more examples to look at. So this first one is from your in-class work that you were given. And it's asking us to find the force in members FD, BD, and also the components of the reaction at pin C that exerts on these two forces, or these two members. So I'm going to start, I guess, by taking this member EC, and EC I would have, at E, I would have a reaction, let's see, EX, and I would have an EY, I would have a CY, and a CX, and then I would have FD and BD. And this would be, what, 1 meter? And this is going to be 2 meters. And these two are two force members. There's only a force applied here and here, here and here. So I know the angles of that. And this one would be 2, 1, square root of 5. And this one would be 1, 1, and square root of 2. So if I look at this free body diagram, I have 1, 2, 3, 4, 5, 6 unknowns. Too many unknowns for a 2D equation. So I'm going to come back to my original problem, and the only place that I really have anything that I know is at G. So I'm going to take that member, and I'll have, let's see, 6 kilonewton force applied here. I'm going to apply my EX and EY in opposite, equal and opposite directions. So that would come EX and EY, right? So that they're opposite directions of what I have here. And same thing for FD. So FD is pointing down there, so it's going to be going this way here. So this will be FD, and this angle is 2, 1, square root of 5. This distance is 1 meter, and this distance is 2 meters. And now I have 1, 2, 3 unknowns in 2D. I have 3 equations I can use. So I'm going to start with the sum of the moments about E. I'm doing that because when I do that, I only end up with 1 unknown, so I can quickly solve for that. So I will have 6 times 3. Then I'm going to have FD 2 over square root of 5. That's going to be negative, and the distance is 1. The x component of FD will go through point E, as do EX and EY, so they don't contribute. So then we get FD is equal to 20.1 kilonewtons. And then I can take some of the forces in the y direction. And I have negative 6 plus 20.1 2 over the square root of 5 minus EY is all equal to 0. So EY turns out to be 12.0 kilonewtons. And then I can take the sum of the forces in the x direction is equal to 0. And in that case, I have minus FD, so minus 220, and that's going to be 1 over the square root of 5 plus EX. And so EX turns out to be 9.00 kilonewtons. So I can then take these values that I found and plug them in over here. So my EY becomes 12 kilonewtons this way. EX is 9 kilonewtons. And FD is 20.1 kilonewtons. So then when I come back to this member, I have, let's see, 1, 2, 3 unknowns. And so now I can solve that with my 3 equations. So if I come and look at this one, I'm going to take, let's see, the sum of the moments about C. Because again, when I do that, I only get the 1 unknown I can solve for. So if I take the moments about C, I'll get 9 times 3 It's going to be positive, and then we'll have FD, so 20.1 times 1 over square root of 5, and that is going to be a distance of 1, and it will be negative. And then we'd have BD, which would be 1 over the square root of 2, and that's going to be a distance of 1, and that would also be negative, and all of that has to equal 0. So my BD, if I solve for that equation, is going to be 25.5 kilonewtons. And then I can do the sum of the forces in the x direction is equal to 0. So I get negative Cy plus 25.5, 1 over square root of 2, plus, let's see, FD, which is 20.1 over 1 over square root of 5, minus EX, which is 9. And when I solve that out, I get CX is equal to 18 kilonewtons. And then I can take the sum of the forces in the y direction is equal to 0. And I get 12 minus 20.12 over square root of 5 plus 25.5, 1 over the square root of 2 plus CY. And CY turns out to be 12 kilonewtons. And the nice thing about these types of problems is then I could then say, I'm going to take the moment about maybe D. And you could solve this to make sure that you have the right reactions here at C. Because when you take the moment about D, I should have, let's see, that's probably not a real good example because we're going to end up with, 9 times 2 minus CX, which is 18 times 1, and that clearly equals 0. But you could take the moment about somewhere else and kind of double check to make sure that if this doesn't equal 0, then you know that you've made some kind of error there. But your answers then end up being FD is 20.1 kilonewtons, your FB is 25.5 kilonewtons, and then CX 18 kilonewtons, and that's going to be to the left, and CY is going to be 12 kilonewtons down. Notice that I have these arrows here because I need to know the directions. FD and FB are two force members, so that has to be along in that member, so I don't necessarily need to give a direction. All right, and then the second problem that I wanted to show you today is this one here, a machine that has a weight of 80 pounds. So this is going to be an 80-pound force. Is hanging from a pulley, and we want to know what the reactions are at A, at C, and at D. I think I got a few things kind of